Now that we understand the fundamental concepts around scheduling, it's time to learn how we submit a job on an HPC system. We will look at 2 sample scripts for a typical batch submission using PBS and Slurm. Before we dive into the scripts themselves, let's refresh some important concepts. Remember that in HPC, a job is a computational program often intended to give us a scientific output. The job itself is more than just the name of the executable. The job includes all the information needed by the workload manager to run the user's application. This includes the input data and parameters, environment variables, descriptions of the resources needed to run the application, as well as the output directives. Jobs are typically described and submitted to the workload manager in the form of a job script. Job scripts are program files which contain the requests for job attributes and use directives which are specific to the workload manager installed on the system. Job execution starts with the job script being copied to the first compute node in the allocated list. The job script is then executed and the application is launched across all the allocated compute nodes from the first compute node. Typically, multiple tasks are launched across multiple cores, GPUs, and nodes, all confined in the job's allocation. The process of running a job typically goes as follows. A user sits anywhere remotely on his or her local machine and accesses the HPC system over the internet. Most often, they are using the SSH protocol to access the login node. From there, the user has 2 choices. Either they can start an interactive session on one of the compute nodes to run the test program and perform some debugging, or they can submit a batch job to the workload manager via a job script. The submitted job waits in the queue until sufficient resources are available to accommodate the job's requirements. A job script has a basic outline. Typically, it consists of 3 parts. The hashbang is the first line of any bash script. It tells the computer how to interpret the remainder of the script. The directives are the batch system-specific lines which tell the scheduler what resources are being requested and for how long. The last part, the commands, are the bash commands used to launch the job. These commands will be executed sequentially, as if they are being typed into the bash shell. In order to specify job requirements appropriately, we must know what it is we are asking for. Let's do a quick recap of some of the important concepts needed to request compute resources from a batch system. A cluster contains a number of compute nodes. Each of these nodes has, among other things, a motherboard, which has one or many sockets into which you can plug CPUs. Each CPU may have a single core, also referred to as a processing unit, or it may have multiple cores. Each core is capable of running one process or task, which is a sequence of operations at a time. By this logic, the total number of processing units is equal to the total number of operations on your system that can happen at the exact same time. Recall that this is known as parallelism. Also recall that a process may consist of multiple threads. Multiple threads running on a single processing unit must run concurrently. This implies that processing time is divided between the threads, meaning that applications can do a number of things efficiently without having to wait for other threads to complete before they can run. Depending on whether your program is sequential, multi-threaded, or expected to run in parallel, you will need to specify these resources to the scheduler accordingly. You must have an idea of how many nodes, sockets, cores, and even tasks you want your program to run on. Different batch systems have different ways of asking for these resources. Check out the next video for a deep dive into job scripts.